installation, which is required to load the image. Yeah. 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 Okay, so these are the instructions on the web page shown on the screen, which we can use to install Docker. So essentially the first command, so for this, the people who are using Windows, they have to go into WSL first. And then we will start a Docker. Docker basically is a kind of a container, or we can think of it as something close to a operating system, a small operating system, something similar to Singularity. So you can copy the commands as well from the web page that is shown, which is docs. Okay, I will share the link on Teams. So for the first command, did you able to run it to just remove the Docker previous versions? Yeah. So yeah, other thing I wanted to ask is like, is there anyone trying to install Docker right now, or should I go with it? Because the thing is, in my machine, Docker is already installed.
Even if you try to install it, it will take time.
Yeah, it's a 500 MB package, so it will take some time. So, but yeah, we can go on with the installation of Docker. Yeah, so what this process did was, it looked for the older versions of Docker, and if there are any, it just removed them. Now what we have to do is we have to set up the Docker's URL in the repository. So the thing with Ubuntu is that there is a repository wherein there is a ledger in which it looks for some URLs from where to download the package, which will be considered as legitimate packages. So we need to add the key of Docker into that repository. Set up Docker CPT. Then in case if anybody is installing Docker, then up till this point, is he following me? he or she is following me, or are there any issues? So the next thing we can do is we have to do is to install the latest version of Docker. Then yeah, so after this we have to verify whether our Docker installation is uh, successful or not. So what we will do is we will do just docker run. What this command does is it will load a image called hello world from the Docker repository. So first what it does is it will look locally if it is present, or and in case if it is not, it will download that image, and then it will mount that image in the form of a container, which is kind of a operating system, wherein it will just print hello world. So that's what this first command says, pulling from library. Yeah, so this is what the container does. It prints hello from Docker. So this certainly shows us that Docker has been successfully installed. Now, the next thing to do is to install NVIDIA Container Toolkit. So why do we require? Yeah. Okay, fine, fine. Which? Haha. Uh, this thing, can you check it? What is the issue? So to online users as well, up to this point, are there any doubts? What? Ah, yeah, yeah, yeah. Everything is there. So we just have to copy from there. So for Windows users, you have to run these commands inside WSL and not PowerShell. Just copy from here. Yeah, you have to just copy with this and paste it in. That's it. That will be executed. Everything will be executed. Oh, yeah. All stuff happens. Yeah, yeah. So while installing Docker, one can copy all the commands using this. There is a small pop-up button there. Just click on that button. That will get copied, and open the terminal and just paste that command, all those commands. Yeah. Okay. So this is how it can be done. Yeah. I hope I am audible to everyone. So as for the online users, yeah. Can we move on with the installation of other things, or is anyone currently installing Docker? Okay. In here? Okay, install. Fine. So shall we move ahead with the installation of NVIDIA toolkit? Okay. Is it done? Okay. Sorry, what?
This is not able to find my locally. This then you can go for the
Yeah. Okay, so that is working. I mean, only two commands. It won't take much of a time. So now we need to install NVIDIA Container Toolkit. The reason we need to install NVIDIA Container Toolkit is for Docker to recognize the GPUs, because by default it doesn't do that. So for that we will require NVIDIA Container Toolkit. It has to be installed system wide. Then it will recognize GPUs, and only after that we will be in a position to run that Docker image, to run the code. So like we will proceed with the installation. Same as in Docker, it will first add in the repository. I mean, we need to add in the repository. Then, so this command sudo apt-get update. So still installation is going on. Docker, excuse me. Okay. So should I stop or should I? Okay, fine. I will wait for some. Yeah, just into Google search for NVIDIA container. NVIDIA container. You can wait either, or you can go ahead with the steps. First two steps here. Or just wait, I will go through. Yeah, NVIDIA container tool. Yeah, this one. APT first, this one, and only I am here. So like just one step. You just add this one. So the thing is, at the top right side, you can, if you hover there, you can copy. Yeah, this will be copied. Just go to the terminal, shift control, and shift control. We will paste all the stuff and just press enter. So can we move on to installation of NVIDIA toolkit, NVIDIA container toolkit? Has everybody installed Docker? Okay, fine. And online as well? Online participants? May I know? Oh yeah. Huh? No. The thing is, the code has been specifically developed for NVIDIA GPUs. It will create issues. Yeah. That has to be rectified. AMD you have. Okay, then OpenCL version. I guess tomorrow or day after tomorrow, we have OpenCL version as well. That might be helpful to you. Okay, so now let's install NVIDIA Container Toolkit. So we have added the path to our repository list so that it recognizes the NVIDIA Container Toolkit as a legal package. And then what we need to do now is, by updating it, what basically it will do is, it will just reread the register. And it will, this time what will happen is, this time it will recognize that anything downloaded from the NVIDIA source is a legal package that can be worked on. So the next thing to do is, after apt-get update, apt-get install by container toolkit.
Please open your sharing the screen.
Is it? Am I not sharing? It is shared.
Or stop sharing and again read.
Screen 1?
Just share the entire screen.
No, it shows me screen 1 and screen 2. Okay, I will just remove it.
Why? This is okay. Just go. How do you go?
Where you want to go? That's what I'm saying.
It's not showing the entire.
Yeah, screen 1 this time. Just check. That's what I told you. Check whether if I am going to terminal, are you able to see? Yeah. Okay, so now is my screen visible? Yeah, fine. Okay, so yeah, I just installed the NVIDIA Container Toolkit. Are you guys following it, or do I need to wait? Like, if installation is going on, then I will wait before I go on ahead. So is installation done or going on for NVIDIA Container Toolkit on your machine, in case you are installing? Then I will move to next instruction. So is the NVIDIA Container Toolkit installed? Okay, great. So the next thing to do is to configure Docker such that it recognizes the GPUs. For that, we need to run this command. For that configuration, configure Docker. Yeah, this thing. Sudo NVIDIA CTK runtime configure runtime Docker. So if we run this, config file does not exist using empty config, root updated config to docker daemon. It is recommended that docker daemon should be restarted. Yeah. So what we can do is we can either do bash or we can just restart docker using systemctl. Yeah, that's it. So to check whether docker is now, we are at a stage where we can load the docker image which has been created with the NVIDIA HPC. The only thing is the hardware requirement should be met so that NVIDIA HPC can be installed. And roughly speaking, the hardware requirements are like it will work on all the GPUs, NVIDIA GPUs, which are manufactured in 2019 or later. So that is the only limitation so far. So docker run. Docker images just permission denied. Yes, sudo. So to check whether things are working properly, what we can do is we can just write the command sudo docker images. It will show the hello world image, which we just ran to see if docker is working. Now after this, that image can be loaded. But as of now, for today, what we will be doing is we will be loading it on cluster rather than individual computer, individual app.
What is the process to
So we can at least load the container. Na? There. Okay, fine. So you have the image here. But that is the thing. Na? They won't be able to load it on their individual machine if you show.
They are showing the demo how to do it. They won't even have image to supply.
Yeah.
It's like just a sample thing.
Okay, so as of now, for a demo, what we will do is we will just load the Docker image in one of the laptop that has a working version. I mean, the NVHPC is working over that, and then we will supply the Docker image on the web page so that you can as well load it if the hardware requirements are met. So you are done. Just unload the image and show me where it is, the tar file, where tar file is.
Select it.
Yeah. So now Achyut will demonstrate how to load the Docker image. uh, in one of the laptop that he has in which it is working. Okay, then and after lunch we will work on containers in on a cluster, so that you can also try it and make it there. Yeah, yeah, we have just working yeah, fine, fine.
Stop sharing.
Yeah, I will just stop sharing. You just show the demo and then we will go for that. You can I will just take a lunch. Yeah, I will see this.
So, so I will just demonstrate the demo how to just load the Docker image if you have it for later purpose. See, the Docker image is like 25 GB. Now it's not able. We are not able to provide you the 25 GB thing. So later we will compress it and we'll upload on the drive and we will provide you the link. Then you can load it and run it according to the whatever simulation you want to run. I'll show you the example file. How do you load the Docker file? How do you run and everything? Okay. So my screen is visible, right? So I have the two .tar files. The .zz is the compressed version of it. Okay, we will provide you this file and you can untar it. You will get the actual .tar file. Now you can load this .tar file using this command. Okay, sudo docker load -i and you just press M and tab. You know that, right? And you will get the actual the file which you want to load. It will take little time because it's like around something like 20 GB or 24 GB. We will upload it. It's like some 20 GB. So
Yeah,
I'm doing it. Yeah, it is doing screenshot. You are able to see, no? This guy is also on Teams. He is able to see. Maybe lag itself. Just it's okay. I'll reshare it.
just reshare it.
Okay, 1 second.
Because it is visible here.
He was able to.
Okay.
Now? Yeah. It's there. Maybe ask him to just download it. Okay. So you can see that it has loaded the image. You got the prompt, right? So you can see the loaded image with this command sudo docker images -i will give you all the images whatever you have. So currently these are the other Docker images I have in my PC. So the first one is the one which we loaded. Okay, with the .tar file. So the KKS FD CUDA underscore MPS UFFT NVHPC, this is the one. This one is our current Docker file. Okay. See, you can see the size also 25.7 GB, which is around use. Okay. So now we have a Docker image with us. Now we have to load this image into the container so that we can run our files. Okay. So that you can run the container, start a container using this command. Yeah, you have to give this command like ---- GPUs all. Okay. What is it?
That attaches the GPUs.
Yeah. What is the command here?
Volume.
Yeah, ----
Slash the dollar. Close parenthesis, then colon slash src verb dir, then slash space slash src. Now the image. So you have to explain all the arguments.
See, this is the command to create a container, and here we are creating a source file. So the source file is like one directory which you have in your any of your folders, like desktop or documents. Whatever you run in your Docker. Actually, let me start with the Docker image. Your Docker image has the NVHPC and whatever the what we call modules or packages, everything we have inputted into the Docker image and we have committed that. So you don't need to install any NVIDIA NVHPC or anything in your laptop except the toolkit. Okay. So now the Docker will take care of all the We can start.
So now we will start the second session, which is a hands-on session for to run KKS CUDA codes. So let's look at the list of things that we are supposed to do. I mean, it will give us a rough idea exactly what are the things that we have to do. So firstly, we have to create a mini conda environment to run the infile generator. So in the previous sessions as well, you must have done this thing. So like, was it inside Singularity or you created a mini conda environment? Okay, it was inside Singularity. Okay, so then it would be a better idea to create a mini conda environment at a local machine, because the thing is that we cannot run GUI inside Docker. So, and Docker will be running on cluster, and the same is true for the cluster as well. So it doesn't make any sense to create a conda environment on a cluster. So on our local machine, individually, every one of us can create a conda environment and run the infile generator. And with that, we will generate the infiles for the following tasks that we have that we have designed to demonstrate the capabilities of this code repository. Then the second thing what we have to do is we have to run the Docker. And while after running the Docker, the thing is that we have to take these infiles from our local machine to a cluster using file transfer protocol, which is termed as SCP. And the same has to be done after running the program, because that will generate the data files. So all those data files has to be taken from cluster to our local machine using SCP. So this, all in all, this is the process that we have to go through for each task. So first thing to do, we will go through the creation of mini conda environment. Okay. Yeah, for that we will go to the MicroSim GitHub webpage, where instructions are given, and from there you can just copy the commands which are required and create a conda environment. Although I will create a conda environment right away. So this is the infile generator that we need to install. It is a Python GUI application. We will be doing this on our local machine. So each one of us can copy this sh script. Miniconda, is it? Is Miniconda already installed on your machine, or do we need to install that one as well? I just wanted to know. So just type the command conda in terminal, or which conda, like which. So in my case, I don't have conda installed, so that's why there is no output. But in case if you get some output, then you can skip some of the initial steps. So how is it? Sorry?
The conda version, Python.
Yeah. Actually, that gives the directory where conda is installed. The path of directory. It will give the path of the directory where conda is installed in the file system. Sorry?
You're not installed it.
Yeah, in this situation, it is not at all installed. Or the other command could be conda version. So it says conda command not found. That means conda is not at all installed. So mini conda again is something like a container, but this is for Python programs. So it creates a isolated environment which only runs Python. So like it won't run other languages. It is just for Python. Okay. So we can start with the installation of conda in case it is not present. So you can use wget to get this sh file. It is a script file basically, and upon running this script file, you can install the Miniconda. I mean, all the commands are written inside that script file. Yeah, yeah, I will share the link on chat. Yeah, so we have this downloaded now, Miniconda 3 Python 310 underscore 23.1.0 hyphen 1 hyphen Linux x86 64.sh. Yeah. Yeah, so is the file downloaded? So after that, we need to source this Miniconda environment. Execute binary file. Okay, go. Slash. How to? Yeah. Source dot slash. Oh, why? Generally it used to work, no? Should I grab it? Okay. Yeah. Yeah. In here. These are. This is the permission.
Execute is not there, no?
Yeah. Okay. Yeah, yeah. So after downloading the .sh file, we need to change the permissions of Miniconda file using ch command, chmod 755 Miniconda 3. This command highlighted. Then after changing the permissions, we can run this .sh file using this command /miniconda .sh, and this will open something like this: welcome to Miniconda 3 5310. So just we have to go through the setup. So these are all the terms and conditions. We just need to go at the bottom of it, and then it asks for yes or no. So just we need to type yes, and that's it. Uniconda will now be installed into location. So this is the place where it asks whether we are fine with this path for installation of Miniconda. So up till now, is it fine? Or
I think they are fine.
oh,
How many have downloaded Miniconda.sh?
okay.
How many are downloading?
Okay.
Just wait a few.
Yeah.
Yeah. So if you have finished downloading, you can just raise your hand.
Yeah, that will take you MicroSim. Miniconda is not downloaded. That means
Showing in the index.
then Miniconda just write Miniconda. माइक्रोसिम को हाँ मिनीकोंडा को कर सकते हैं
मिनिकॉन कॉपी करके दे दो
उसमें just copy in there and give it to the .sh. Although it's a pretty small file, most of the people can download it. It's pretty small.
Okay, so I think we can go ahead.
Yeah.
Everybody has downloaded, right? No? What happened?
What's the issue?
It's downloading still.
We have that sticks.
Sticks.
USB.
Six. You just distribute the sticks.
Yeah. Yeah.
There's only one stick.
MPA. Sudo. Use sudo.
Sudo, not sudo. We have to change the permission CHMod.
Okay, yeah, chmod. Which chmod change it?
I'll tell you.
Do chmod space 755
Who else
space
is downloading
miniconda.
it? Who else is
Miniconda.
downloading it?
Press MINI and then tab. So
We can
run
show.
the.
We can directly show to all of them. Everyone will be.
Okay, I'm done. No, it is going on. It's okay. How big is? Yeah, it's 74 MB. Okay, fine. Yeah, this is done. Then
These
Who has not downloaded it? Which file to copy you discussed?
Yeah, that Miniconda, capital M Miniconda thing.
it's in a folder KKS CUDA.
Display the name of it.
Yeah. So to change,
Just copy to your PC and then just pass it to the other one.
so after downloading Miniconda, this command is to be run, which will change the permissions. What? Okay, okay.
After downloading,
Yeah. Yeah, you can run this command after that as well. Although not required, but you can run this. This chmod to change the permissions. Because I have already ran it, I have already changed it. So it's not required, but for safety.
and create the link and make it open. Tanmay,
Two, three.
this is only readable. I have to. I don't need to. I just want you to email it. So I tell you that file. Yeah, uploaded in my OneDrive. So this is
So is the sh file downloaded and permissions changed? Are the permissions changed? So you can run in this command .miniconda to enter the setup.
private, no connection. Start showing. Anyone should be anyone demo purpose. What is the next file I have to do? Wait, nothing is wait. No, wait. Wait, just wait, just wait. See, it's a setting. It will download setting. Because there are instructions we cannot do it. We can just download the system. The commands are not there. That's why I said wait. Yeah, done.
Okay, so did you all entered into the? So in here, where we have to pass on the path of Miniconda, just press enter, and that will just install Miniconda and download certain repositories. So yeah, you can enter yes. Yeah. So at last you will see it says thank you for installing Miniconda.
If you do which code now, it will show the version.
No,
No, no,
No,
you
no,
have
no.
to do that bash HRC. Did you do that?
Which bash is RC?
So you install it, right? What is the next
Yeah.
step?
Next step is to bash, no? Do bash RC or run bash RC. Yeah, yeah. So now Miniconda is installed, but in order to verify whether Miniconda is installed, we need to restart the shell. So for that, the command is bash. It will just rerun a file, system file, which is called bash rc. Okay, okay. So source, we can also use source./bash rc. It should be here, no? .bash rc. Yeah. So as you can see, there is this base command written in the terminal window in the bracket that tells us we are in the base environment of Conda, and it tells us that Conda is successfully installed. So up to this step, are there any issues?
That is not working. So that was very transparent. So this shell got it now. That's fine. So these are some like shell matters, type of shell matters.
Yeah, just check. So shall we go ahead with the installation? Yeah. So now we have to create a environment in Conda, which will install Python 3.9 and a package called pip, which is a package manager for Python. And oh, no, I didn't. Okay. And the name of this environment will be MSENV. So just
So pay attention. What he is doing is creating an alias for this environment, which is MSCN. Okay. So
yeah. So after creating the Conda environment, so is it created or? Hmm? Yeah, yeah, sure. Yeah, this is the command that can be used to create a Conda environment. Conda create name. It is also given on the MicroSim web page. MicroSim GitHub web page. There it is given under the heading in-file generator in README. So is this done? Is Conda environment created?
What is wrong with this command? Why this is such recurrent? Enter. Which file log? No, no, no.
Of OpenFOAM 7. Why it is looking at OpenFOAM 7? OpenFOAM was installed in this WSL.
With bash it's working. Why are you doing this?
Yeah, with bash is
I didn't see that.
with bash it is working.
वो हो गया.
The direction path. You just press some random button to accelerate some direction.
Okay. Done. Everybody reach cut till here. MSCNV. Okay. Chalo.
Yeah. Okay. So now we have created the environment. We have to activate that Conda environment using the command Conda activate MSENV. So now, yeah. So in here we can see that we are now in MSENV environment instead of base. Yeah. So is it done up till now? Then we need to download some packages and install them inside this environment.
All these comments are in the link posted in the chat box of Teams. Or if you are not in Teams, you can even go to the MicroSim web page online and just scroll down. You will find this in the README.
In the README, there is a section in file generator. In there, the instructions are given. How can we install MicroSim and all the stuff. So we are going through those instructions only, step by step. So are we all there in MS ENV environment? So can I go ahead with this? Is it? Okay, fine. So these are some packages that are to be installed in order to run the GUI.
Just copy it from the ICME website. That's
Yeah.
the easiest.
Yeah.
ICME MicroSim website, you just copy this installation, this thing, that will be the easiest, because if you type it, something will go wrong. Everybody found the command on ICME MicroSim? Yes? No? Yes? Yes, sir? You have found out the command? Click. Conda activate MSNG.
So permissions, most probably. I mean, it's not creating. With Conda create, we create an environment.
Hello. Hello.
Yeah. Okay.
Hello. Hello, sir.
Hello. Yeah.
My question is that in this MS environment, I am downloading this PyCalphad and other things. And
Okay.
this PyCalphad I am using, I am downloading because I have to read the TDB file.
Okay.
Is it so? Hello. Did you got
Hello.
my point?
Yeah.
I am saying that.
Yeah. So the thing is,
MS
can you speak a little bit louder? You are not audible, actually.
Okay. Just let me. I am saying that I am downloading this PyCalphad and other parameters, other things in this MS environment.
Okay.
This PyCalphad will be used for this reading the TDBs. Huh?
Yeah.
This
It will be used for that.
Okay.
Yeah.
So further, I need not to this download PyCalphad from somewhere else.
Yeah.
It will be sufficient.
Yeah. So the thing is, whatever you download here and install in this environment won't affect your machine as such.
Oh, okay,
Once
okay,
you
okay,
go
okay.
out of this environment, it won't affect your machine. So like you have to activate this environment, work with this GUI, and after your work is done, you can deactivate the environment. That's it.
Okay, okay, right. Okay, okay, okay. Understood, understood. Okay, thank you. Okay.
Okay, fine. So did everyone install this packages through MicroSim? Okay, download is going on. Okay, fine.
Run with the downloading and installation.
It's downloading, I guess.
How many are done? Okay, that
Okay, it's downloading. Let's wait for 5 to 10 minutes more.
I think the back Okay, let's go ahead. Okay, Anna.
Is it done? Okay.
Not done. It's downloading. Okay. So go to your MicroSim directory that you loaded.
Yeah.
Then you have it on your home directory. No, you have downloaded MicroSim.
Just open the MicroSim directory. CD, capital M, just press tab. You will open the MicroSim directory.
This you want downloaded the first day.
Yeah.
There on your machine. Home directory of your Ubuntu home.
So from there on, we can now run the Python script that is there, which will run the GUI.
So this is the same way that you did before, Python 3, microsim.py. Launch it in the same manner.
Yeah. So this is how we can create. I mean, this is
Everybody able to open this?
This is the infile generator, which is required to generate the filling and input file to carry out the tasks that we have for today, the problems that we have for today. So till this point, is it done? Should I go ahead or should I wait? Okay, it's not done. Things are going fine.
Actually, very slow. It's better to do a dual boot than this. also required.
Yeah.
Pushkar.
Okay, so we will continue with the process as all these things will be recorded. So in case you are stuck somewhere right now, you can continue from there on from the recordings. Okay. So majorly in this, we will be using two functionalities, namely import in file and post processing. So with this, we have to create the in file for problems that we have in hand now. So in here, just select KKS GPU CUDA model, and then it asks for choose in file. Then there is a folder, yeah, workshop MicroSim 4. And so for the first task, we have to select this file, input tdb new nialmo ppt.in. From this in file, we will generate the filling. Yeah. Yeah. Yeah, but the thing is, we need to move the in file. So you must know where it is being saved, because we have to upload that to cluster. Okay. If that is possible, then go through Singularity. It will be better, because you might face error.
No, the thing is, we will go by Param Seva rule, and then you have to give password. So that will log in with someone's PC. Yeah. So how do you generate it?
No, so let's open this in file. This will be used to generate. And do you have this in the text file, in the document, the problem? So do they have this?
They have.
Okay, so you can navigate to this file. There are problems. I mean, this what do we say? This pages you must be having with you. So in the first problem, we have to just modify this nialmo ppt.in. Yeah, yeah. You can generate in files from Singularity. So we have to mount Singularity. You might be knowing how to mount Singularity. Mount it, then open GUI, generate in file the way we are generating. Then you have to copy that in file to cluster. We will give access to there, and then we will make it using the Docker image there, so that nothing has to be done. Yeah, you can open another terminal. So in this, we will set mesh to 200 by 200, and then yeah, the discretization, just change it to 1. Delta t from 1.5 e power minus 9 to e power minus 10.
Same था ना? Single. So whoever is able to open Singularity, just open Singularity. You have loaded in the first day. Generate the in files following the same procedure, and run it using the Docker image that they have shared. Okay? That is the easier way.
Okay, so the number of phases will be 2, number of components will be 3, and the time steps, most importantly, it should be 20,000. Yeah, as given in the task 1, and we will be saving at 1000. So num workers has to be 1, because yeah, Yeah, it just depends on number of GPUs. So as of now, we will go for only single GPU, although it can run with multiple GPUs as well. And all the other properties, this all properties has to be same. There is no need to change it. This as well. And in here, we have to ensure that we are using function F4. And in the last tab, yeah, this all properties are to be remain same. Then we can go to next page. So for phi, again the boundary conditions will remain same. And in this domain filling, we have to add a cube for planar solidification. So how do we add? We will add a cube of alpha, and in this S should be 0, 0, 0, and the endpoint should be 200, 0, 0. So what it will do is, yeah, it will be a straight line, straight vertical line at one end. Okay. Then we can go next and then select the model. Yeah, so select a model KKS GPU CUDA. Then we can go next, and in here we have to make sure that elasticity is set to 0, and in here and the other thing is equilibrium temperature should be 1200, and the temperature we have to get two results, that is for 50K undercooling and 100K undercooling, that is for 1150 and 1100. Okay, so for now we will create a in file for 1150.
Can you just continue?
Two dimension. And the gamma ABC should be set to 0. Now in here we can modify the name of input file and filling file. Task1.in, task1.in, task1.out. So what it will do is it will generate those files. So we can choose where to generate those files. So yeah, we will create a new folder called task1, and we will open this. Here it will create files, successfully created input files. But the other thing is, now what we need to do is we need to copy the TDBs encrypted, because it uses TDBs encrypted. So this there is a folder called TDBs encrypted with every task provided. So like it is provided in a folder called Nialmo PPT. In this there is a folder TDBs encrypted. We have to copy it and just paste it in task1. Okay. Yeah, sure. So in here, from which point? Okay, from the start. Okay, fine. Yeah. So firstly, we have to import the in file. Then go to KKS GPU CUDA model. Then choose in file. And in
Input file Nialmo PPT.
yeah. So we have to go to Nialmo PPT folder, which has been provided.
This is your NSF folder.
Yeah.
NSF, you will find the workshop MicroSim. Okay, that the subfolders. Go there.
Okay. Then in that you have to go to input tdb new nialmo ppt.in. Nialmo ppt.in you have to select for the in file.
Underscore ppt.n, not the binding.
Yeah, got it. Then change the mesh to 200 cross 200 and the dimensions has to be 2. Then in discretization space and time tab, you have to change delta t to 1.5 e power minus 10 instead of 1.5 e power minus 9. Then next, here we don't need to change anything. Number of faces will be 2 and number of components will be 3. Then in time steps, we have to change it to 20,000. And save at 2000 so that we get 20 files to look into. So we will be able to see the evolution. We can do it as 500 as well. It will generate 40 files. And the num workers had to be set to 1 because we are working on single GPU, but multiple GPUs can also be worked. But the cluster that on which we will be going to work has only one GPU. Huh? Tau is 1. Okay. So next. Now in here diffusivity and elasticity tab, all the values will be as it is. No need to change it. We can move on to gamma and other constants. Here also we don't need to change anything. Then in functional properties, just ensure that function f is selected as 4 and that's it. We can keep all the remaining things as it is. Then in phase composition properties, there is nothing to be changed and we can go to next tab. Yeah, in here in boundary conditions also we don't need to change anything. Then for domain filling, we can fill in, we can select the shape cube and face as alpha and then add a cube. So am I going fast or are you following it? Yeah. And so the starting point will be 0 0 0. Since it is a 2D simulation, so Z will always be 0. So start point will be 0 0 0 and the end point will be 200 comma 0 comma 0. The reason of taking 200 is because our mesh is 200 cross 200. So it will create a planar solidification front. And then we can go next. In here we have to select a model which is KKS GPU CUDA. Then we can next. And in this KKS GPU CUDA model, we have to set tau as 1 and gamma APC as 0. And elasticity we have to set it as 0 as of now. For any doubts? So tau is generally a measure of relaxation per. Okay. Okay.
So it's the internal, this is the relaxation constant in the phase shift. So the equation that is always tau epsilon dV by dt is equal to, so that's the relaxation. So that we typically set a calculator in a way that we get repeated control. Okay, so there is a way that you can estimate the property given the property as a combination. So you can actually calculate it. This is for a equation when you do range bound type process where the mobility of the range can be set depending on the range property. So that is where now the part of this one.
So in here we have to set epsilon as 16 e power minus 10. Epsilon is the interface width that we need to set in for our phase field model. Yeah. So this is how we can create the tasks. We can create the infiles and just then select the directory where you want. So let's just keep it this directory. So yeah. So in here now this files filling task 1 and input task 1 are created. So what we need to do is we need to transfer this file to the cluster.
If you have,
So we can close the GUI and then to connect to cluster, we will okay. So yeah, I will open the text file, and it will do is it will generate a folder called data. Yeah. So this data has to be taken out from cluster to local machine. That is to be. Yeah. Let me check once again. I guess it is ready. I got it. My screen is being shared. No, I guess not.
I have to source the CUDA setup file.
Yeah, is it shared?
So yesterday also we generated data. So what is the difference? What speed only difference?
Yes, speed and the model is different.
Same model I can do yesterday's style also.
Yeah. If the model is same, we can do it. So yesterday as well, there was a planar solidification, but this time we have a CUDA KKS model. Yesterday it was grand potential.
This CUDA setup file. This content.
So it was
Now
open.
how will we transfer?
So for that we have to transfer using some command called SCP. So we have to take data.
Okay, you will email me back.
Yeah. I will email you back, or maybe I will give you data in pen drive.
Okay, can you just give the access? I will be providing it. Not this.
I'm just providing this to the.
Yeah.
If you have this file in this folder, you can just source and then you can just and source it. And source it.
So I will.
That personal content on the path.
You have the data? Yeah. Okay, fine.
So this file you are going to give us in PDF now?
Not right now. I will just first show this thing, and afterwards I will give it to you. Okay. Okay. So
I have the source of the code and bits and also where I'm getting this
yeah. So the thing is, so first what? Fine. My screen is recorded now. Yes. Yeah. Screen recording is on. Screen is being shared. Yeah. So first thing is we have to make it. We will just make clean it. What clean does is it will just clean all these objective files which are created. So like what happens is C file, there is a .c file. When you compile it, it will create a .o file, and then we run that .o file. So what this command does is this just removes all the .o files. Okay. Then we will do make clear. What make clear does is it will remove all the data that has been generated, VTK data that has been generated. Then we have to compile it. We do using make command. So this is compiling all the stuff. Okay, so this is your data, na? Yeah. Okay, I will just put it here, and then.
I'll make it make run. You have to provide it where is the filling file and what is the input. This is the rest is the same. This is the only variation between the task which you have given. When you want to perform review simulation with the different parameters, you have to vary these filling files and the input files. That's it. The rest is the same. Whatever I did, like sourcing.
So this is which task? Task 1, task 2?
Task 2.
Okay, cylinder. Task 2 cylinder. Okay, fine.
Only this is the only difference. Filling equals to. Now we have to provide the path for those files which you have given.
So actually, the same problem can be solved by other users, other solvers. Then why we are using so many solvers?
Okay, so the reason why we are moving to CUDA solvers is that we want concurrency.
Okay.
So we want various operations to be simultaneously done, because that will speed up the things. Because when the domain is big, it's pretty much difficult to simulate the entire a bigger domain in like what do we say, like in shorter periods of time, I would say. So I mean in practical periods of time. So for that we go to CUDA.
So computationally it is less expensive.
No, computationally it is not. It is expensive computationally, but the thing is, what matters is how fast we are able to get the results.
Okay.
So for that reason we are using it.
Yeah, some solvers are better efficient for some problems.
Yeah,
No. What is the question? What is this question?
So
if it can be solved with one solver, what is the need for so many solvers?
Because that hardware availability for you. For example, you are taking the NSM machine. You might have only GPU available. During what will you do? You will still be wanting to run, no? So it is essentially the flexibility to run whatever is available to you. Because GPUs, CPUs, all around, these are possibilities. So you want to run the same problem with whatever is available at that time. If it's CPU available, you run it on CPU. If GPUs are available, you run on GPU. That's right.
See, this is our make run. Filling is equal to the path. This is the path. This is the
make run command, and in here I have provided filling argument, wherein the filling file is provided. This is not from your group. This is from another group. I will add in your group as well after this thing. And input is the input file that we have provided, and then this will run the simulation.
So in this code, instead of leaving
Now the entire thing is done. This will generate a output folder called data. So we can see that there is a folder called data which has been generated.
What is
So
that
similarly,
so in that sense, you can actually
I
change the order
will
of the argument.
go to your
So
data.
let's say you want to fill the filling file. Doesn't it?
Yeah, it's done.
Just give the prefix. Filling
Simulation is done.
When you know that
And I will generate.
then order is
For
not
that,
important because it's the prefix assigns which value.
Yeah, not necessarily paraview. We can look into the look this data in the GUI that is provided. So in the singularity image, with that we can view it.
So here they're running on only single GPU because only single GPU is available.
Yeah.
This is a multi GPU code,
But
presently only one GPU is available.
so okay.
That's why they're running on one.
here make sure that
Which is the data?
you can give here also.
Filling to or
Yes, task 200 and input task 200.
Okay, okay, fine.
That num workers key is there, no? In that, if you put that number there, it will. Yeah.
Your table is task of
It is task 2, na?
Which task is this?
Yeah.
One.
So you did 50 Kelvin, 100 Kelvin.
100 Kelvin.
100 Kelvin.
So I have to
And you are doing what?
the task 2.
Cylinder.
So now what I have to do is I have to use SCP to send these files to cluster.
See, this is the local machine thing, so that's why
444 is the port number of cluster.
Okay, P is the port.
Yeah, P is the port and 444 is the port number. Then R is for recursive. If I have more than one files, because I have to send filling
doesn't have the GUI, but the thing
task2.in and input
everything else is there.
task2.in. Okay, and this is the address.
Yeah, it is there.
And then we have to put in a colon and we have to check for the right path. So right now we are in Docker, so we can detach it using Control P, Control Q. Okay. Then it uses the Nialmo PPT in file. So we will go to Nialmo PPT. Then ls there is this file, and in here only we have to copy other two files as well. So this path is required. So I will just copy it and paste it here. Yeah, that's it. Yeah, so the files are transferred there. We can check it. If I do ls, the files are here. Task 2, task 200. But then, okay. So now the thing is, we have to yeah. So there is some issue with the components in the script. So it's a minor issue. So that's why we have a alternate script to rectify that. But we are trying to include that in the make command as well in the future. So right now I have to go there and figure out. I just have to run that script with the input file. So it will make changes in the code correspondingly, and then we can run the code. Okay.
So I think after we complete the task, I think 4 tasks, right?
This is the output are in the MicroSim
Yeah. So in this CD MicroSim
Workshop, output are in MicroSim
KKS
our CUDA
FD.
where you have run the file.
Here there is this file GE data writer. This is used to modify the code file. So what I have to do is Python 3. I already have created an environment called MSW4. Okay. GE data writer.py, and then the input file. So where that input file is slash then NIALMO PPT INPU input. So what was the name of that file? Input task2 TAS task2.100. This is the input file I have to give. Okay. So what it does is, yeah, it has made the changes in the code. Now what I can do is I can do Docker.
Made changes in the input file.
No, so in the code. So like in this file, see, there is functions. There is a folder called functions. So see here there is a folder called functions. Then in this folder there is a file called defines.h. So in that file it has made changes, corresponding changes. Okay.
So every time we have to do the
Yeah, right now it's a temporary thing. We are working on it. We will remove that string. That thing.
That can be avoided by providing the proper
So yeah, so I just need to check whether yeah. Docker PSA. What this does is Docker PSA. It tells me what are the containers that are available. So this is the one which we want. Full files, which is a KKS CUDA MPI CUFFT MP. This container we have to attach. Attach full files. So this now we are attached. Okay. Then we are in CUFFT MPI. So we can again go make clean, make clear, make this will compile it, and then run with the input file and filling file.
What is your this thing? Which program is yours? This is your input file, okay?
Now we will do make run. Yeah, filling is the filling task. This is the one, and for input we will do repeating
Go to this your MicroSim directory. This is a MicroSim directory. Just the name is underscore git.
task 2.1.
That's MicroSim testing. And enter the KKS CUDA. This is the solver which we are using.
So again, what it does is it will create a data folder which has to be transloaded to local machine, and then we can visualize that with the GUI. Yeah, so it is done. So we can check. Yeah, this is the data folder. Since GUI cannot be run in this, so it's not possible to. Right now, it's not possible. We are working on that. So yeah.
So you will give us the data.
Yeah.
This is the GE data underscore right the PY that we have to run this file. Okay. This is root. I'm sorry, I mean root. We have to run.
Yeah. So. Yeah. Okay. So I can give the file right away. So just Control P Q. Okay. Then SCP.
I'm sorry, I was in. Okay. We have to run in the normal terminal, not in Docker.
We can check the data in this local machine.
We have to activate
The data, output data. We can check it here itself.
Activate
In the local machine. Yeah.
We provided.
So task 2, instead of now what I will do is in this there is a little change I will make. So this in here what I am doing is I am giving files on the local directory and afterwards in the CMS lab. Okay. So what I will do is SCP port 4444 R recursively data folder where it is in CMS lab. Okay, so I have to provide the complete address lab at the rate 192.168.162.169 colon and the data is in this directory.
You have to run this command. Here in your you can give this command.
So
now we have
API and data. So this is the data folder that I am giving.
Since we are defining the same directory, where is that? It is in this MicroSim Workshop.
And I want it in this task 2 folder. Okay. because input file will also be required, so that's why I'm keeping it the same folder. And just do a dot means here. Yes. No such file it says. Why? Okay, I just moved to data task. Yeah.
Why there are two files? That is you created both. Okay. Which one you want to visualize?
Task 2.
Even okay, even okay. Under or
Yes.
I just showed them the 100 one. Okay, this is 50. Okay. So this is a
Fine.
Python.
So this is just transloading.
This thing you have to, actually this thing we can add it in the Excel but due to some thing we have to do it. Okay. So this is a part. You know, this is just providing the access nothing. So you run it.
Yeah, this is done.
This is nothing. This should be
So there is this folder data task. I just have to go to files and then I
so now we
will
are done with
just
this.
copy
Now we
this
can go to Docker.
and
So shall I show you how to go in
there is
Docker or
paste. Yeah. So it is copying right now. Once it is done, you can check it in Paraview as well, or else the GUI. I will show how to check it in GUI.
now I am in the base.
We have not used
Yeah.
it GUI.
Yeah, Paraview it is also possible, but there are multiple. In Paraview it is possible. Yeah. So you just need to, huh? Yeah. Yeah. So I'm just giving them the output.
So these are the containers which you have. Okay. And I will load the image.
Okay, Paraview mein, yeah.
Means already shown how to create container using the
Yeah.
image. Once you know the image, we have a command to create.
Yeah, I will just.
Also have a container.
You show them the output how it looks.
Yeah, I have shown.
Okay.
One thing is done.
Okay.
Yeah.
Okay.
So
Contact activate.
now you have to log into this container. Since exited, I'm logging in.
MSENV.
Exited, so I have to
So,
restart it and attach it. If you use without exiting, press Control P and Control
task
C.
we are in.
That still is running. You don't need to restart it. You just have to attach it.
LS.
So I will restart it.
Okay, it's in media, na?
Restart the name. Exited. Underscore class. It's randomly based on being selected. This is the name we created.
I will just show you the output, what the output is.
Itself it's selected. It can be any name, say intelligent, nightmare, vigilant, tosser, confident, something. It's randomly selected. We don't have control over it. So I have restarted it. Now I will attach it. Attach.
Then activate MSENV.
I'm inside the
CD MicroSim.
Now I'm inside it. And see this source folder is
So there is something called as microsim.py.
It is showing everything which I have in there. If you attach some other folder, you just have only microsim whatever, only those.
So it will run the
You have
GUI.
to be very careful. I mean, because that's where you can access the input. Right?
This thing.
So now I'm
Just go. We have to go to post processing.
So I have to,
Then we have to select the in file,
running the file, I have
which is
to
it,
put the CUDA settings.
Pushkar, or this thing. Task 2.
Source.
We have the input file here. Okay. Select it, and then in here this says import VTK. So import VTK. Import VTK. What we have to do is we have to just select
It is in root.
the
Even the microsim,
zero at 5. That's it.
But to make sure we have all your input files, we are not getting that. Here again we are
So
taking from the home
it is
directory.
here.
So in the root,
And
it is
then
the CUDA setup.sh.
If we run it, so this is
Okay, so
Actually,
what you
this
see over
file
here,
contains
what is the undercooling of
all the paths for your
So you see that halo around it,
orange they have some models.
that halo around it is essentially spreading. Play it further.
yeah, it's
So that halo around it is essentially showing you that interface becomes where you are. Okay, typically that is not a good sign. That means the undercooling that you have given for this particular problem is too large for the delta X. That is essentially the thing.
reduce the undercooling to 50 Kelvin and see what is
before running the CUDA file.
same effect.
So now,
Yes, sir. Okay.
Okay.
now we have to run the
We have to import the file.
MicroSim Workshop. Now we have to run the KKS CUDA code. That is in.
So whoever has finished the task, they can have tea.
Task
Or whoever
200.
is waiting.
Okay, it says 50K. Okay, you have 50K now. Oh.
Okay, then we'll check the output of that.
Yeah. So I will just get that one out as well.
Actual code which we need to run is in this code. KKS CUDA.
Yeah, theirs is planar solidification.
So this is the this is the folder which we need to run all the these things. Okay, we need to make it. But since
we have
I
to
have
make
ran
from
already
that
this is the
inside.
earlier one, so I will make it.
Whoever is waiting for the task, they can do it.
Know this thing, right? If I don't do it, I don't need to make clear and make clear. I clean, make clear and general. You can do it
Yeah. No, only I mean in that
I can just
in file as well I can do.
everything is written.
Just give me 1 minute.
That thing of zero is also done. I have set the code of it. I just want to make it. We are compiling it, okay? We provide the input file and filling file while running it. This is just compiling.
Yeah, instead of 1100, we have to make it 1150. But this has to be done in Docker as well because we have to run the command there as well.
You change the undercooling and
Yeah, I'm changing it. Yeah, I have to run it. I'm making it.
second task is 100 Kelvin. The first 1 to 1B.
1B, 1A, 1B. So Docker attach.
Just that you will like to do the more difficult conversions of the data. So
Yes.
make and then here we have to provide the filling and input.
Full files.
So this is the
Docker attach
full. So we have to provide the path here. Where is our filling file? Where is that? It's in workshop.
Okay, so we
So I'm going to directly back.
//
It is in
MIALMO underscore PPT slash
it is in workshop. And then it is in
input
where is your
task task 200. This was the one.
and the file name what is
We'll just change this from 1100 to 1150.
50 no we did yeah. That thing we did 50 only no that's the because
Okay, so when you are changing in Docker,
Yeah. I mean, it eventually generates a text file. So what I am doing is just making changes in the text file.
no, but before this also you changed, like in the text file only you were changing, right? Just before this,
No.
you are doing it for the second time.
Yeah.
Before this, what you did means 1150 change and what?
Yeah. So it was there because that we need in GUI as well. For in the GUI we need to input the file. So there we have to change as well. Because if there it is not changed, then it will create problem. Yeah. So now once in Docker and once in the local machine. So Nialmo, it is changed. Now what I have to do is I have to run Python 3 GE G data writer then slash input task2.in. Okay, yeah. In this window it can't be done because yeah. On this one. So control P key. Then it is an MSMW4. So
actually the same
this Python 3 GE G writer then slash dot slash NIALMO PPT input Yes, task. That's it. Now, yeah, this is done. Now we can again do Docker attach. What was the hopeful? HOPE hopeful vibes. Now we are in the Docker. We just have to make
So now
clean,
we have the input here, the data.
make
This is the folder which is
clear,
the input. Okay.
make.
But we have to run that.
Actually, we don't even need to do make every time. Once it is done, so the code is quite generic. So everything is in the data, input data file. So once make is done, we can do make run every time.
Since we activated it, we will just run Python.
So it is just that I did make clean and make clear, so that's why I need to do it.
So now this post processing. Here you have to select the input file which you have given. So what is the input file? Here we have MicroSim Workshop, MicroSim, task to underscore input task to underpinning 50.8. Okay, this is the input file. Okay, now this is the output file. Coming selected MicroSim. Sorry, this is in the KKS CUDA.
Yeah, then make run F5. It must be there now. Yeah, so this is the same, like input is the same and filling is the same. Okay.
Did you give the conditions?
Yeah. Yeah. So data is generated. I need to
Center of the domain, not the 0, 0. Since you have
so
given
the data is generated. I will just transload it.
if you gave it here, the
And
prefix
that's
will
it.
be center neck will be
We can visualize what the
so
data
0,
is.
0 should not be center neck. Center has to be convert from something like that. That's right. You can see the periodic
There
is
is
also
some error.
since it's 0, so it is periodic from here and here. You can see the periodic order conditions are also included. That's why it's periodic now. The center will be about yeah. I don't believe this guy what is your task? You can ask it, no?
Yes, so set parameters that let's just do it. Let's
Yes, if it's not happening, I can show. Actually, for elasticity, there is something we have to change. The elastic, you see the elastic effect here, some parameters are very modularized. Otherwise, it won't be that quick.
So where it went. So data, MicroSim Workshop, task 2. Yeah, this is the one. No? Okay, it's in home. MicroSim Workshop, task 2. So I will just create and paste in this task 2. And then I can run the open in terminal. Activate MSENV. Yeah, activate MSENV. Then okay, it's in here. New tab. So we have to move to MicroSim. Ls, there has to be KKS CD, KKS. No, there is something called MicroSim.py, which is
PY.
yeah. MicroSim. microsim.py,
Yeah.
and the yeah, that's it. We will specify the input file once it opens up. So for post processing,
So now which post processing you are using for this? There will be the software for the post processing ParaView and
Yeah,
which
so-
you are using which post processing?
okay, so the thing is, this is kind of a separate tool which we have done.
For the MicroSim also, like there is a separate post processing.
Yeah, yeah,
Okay, okay.
yeah, yeah. So in this, this facility we have to select post processing, and in this we have to give the input file, which is in here, task 2. So input task 2 file. Okay, and then the data has to be selected from task 2 data. Yeah, this will be one. Yeah. Okay. Yeah. So we, yeah. So this is
After
yeah.
reducing also it is showing.
Yeah, the reason
50
yeah,
Kelvin, right?
yeah, it is 50 Kelvin. The thing could be the interface width, which is epsilon. That
Epsilon is more, I think.
yeah, epsilon has to be reduced because in phase field models these are diffuse interface models.
Diffuse
So
interface.
unless and until we set up proper interface width, we won't get the convergence.
Even the width is more than the
Yeah.
matrix.
Yeah, yeah, yeah. So like it is shrinking.
Yeah, shrinking.
Yeah. So for that the width has to be even smaller because it is the width is I mean the matrix is diffusing at a much faster rate. Not matrix, the precipitate is diffusing at a much faster rate.
Slope will be
Yeah.
this kind of sigmoidal curve, it will move like
Yeah.
it
Yeah,
will be
that
region is
region of change is very wider. So we have to reduce it. That is the interface. We have to reduce that thing. That thing is there.
For that, you have to activate the icon environment. If you don't do that, you have to do contract
you are giving that
for whatever the name you
we need to take it.
Yeah. So if you want, I can give it. If you want these results, or otherwise that's fine. If you, because everybody from your group has seen, or should I give it? It's in pen drive. So take it. Yeah. So it is in task 2 data and data task 2. Data task 2 is for 100K and data is for 50K.
solver. In this, we have this GE data right? You have to run this. Python. And we have to do the file. That is input file. That input file is in so just make some variations that so in this and in this we have given which is task element. This is your first thing and input file. This is only file we have in the reflection of Achyut. So we have to do this.
You know the address means we can give it a single address.
Yes. I just don't know. I'm just
No, that you are right.
Okay, this thing is done, right? So now we have everything to go into the so I mean this is the Docker thing. Shall I show exit and or shall I can run it?
Do you want to sit down?
Yeah.
What is your I mean
Okay,
I can
so
show
your
you.
output is generated now.
Generated, but we didn't see it back.
Okay, so right now I will show you. Yeah.
I have shown how to come into the Docker. Right? You are inside the Docker. Okay. So you inside you attach the source file, which contains the whole home folder of my OS laptop. It depends upon which you attach. That directly will show me the Docker. Okay. And now before going into this, so in the Docker image, in the Docker root, I have given CUDA.sh file. This is in the Docker image. We have provided uploaded which shows the link.
This is how we download the data using SCP command. Okay.
So it is in Microsoft Workshop 2024. You can go to the root and then you will have this CUDA setup. So in here, there is that file.
Guys, last one. After we finish, so 4 will start.
Yeah, sure.
This talk.
Yeah, sure.
You're able to execute it.
Yeah, sure. So depending upon the installation, we pass on the direction. So just to ensure that we created this .sh file. So we will source it. Now we can run that KKS application. For that, I need to go to the MicroSim repository. Okay. So this thing